Okay, so we're going to look at how to do the EM simulations. So I'm going to make a very short video, and so this is just a standard EM simulation. So the idea behind the EM simulation is, so if you think this is satisfactory, which is probably not, but for the demonstration purposes this is good enough. Now if I go for my circuit schematic, let me just delete this stuff at the moment. Okay, so this is the LNA. So this is slightly different because you have this is two-stage LNA. You have one transistor, second transistor. The last time, so in the review 2, you guys have replaced all these inductors, capacitors with the PE15 inductors and PE50 capacitors. I haven't done it because I just kept them lumped. But anyway, for the demonstration, I'm going to show you only this part here. Now the idea is we have to EM the inductor. Now if you look at the layout of the inductor, you can go to the layout tab, then you'll see the inductor. If you select that separately, this is how the inductor looks like. Now this is just a circuit model and it has the layout associated with it. So if I go back to, so let me move this. So if I go back to my circuit, so the idea is I replace this with the EM block. So I want to create a EM block first. So I have to first go into circuit schematics, create a new schematic. Let's say this is stage 1 inductor 1. So in case you have multiple inductors, so just say this is stage 1 inductor 1. And I go into that. I have to get the circuit model and put it in here. Okay, so it doesn't know the length too, so I have to go and get the length to put it back so that warning goes away, and then I have to put 2 ports. I'll put my port 1, port 2. So this is still a circuit model, so I need to make a, so if I look at the layout, you can see the layout as, say, just the layout of that inductor. The new thing that you do in the EM simulation is you need to add another block called extraction block. So if you click on the element tab here, you will get as a element tab here, you will get to search the element. So I click extract and I get extraction control block. So you say okay and it will come up like that. So you can get the same block in a different way. You can go to the elements tab at the bottom, then go to probably general, set in there, or simulation control, and then you can see the extract block. So I can either get it from there. It's the same thing. Now you need to change a couple of things in this block. First thing you need to do is change EM extract block to a sensible name. Let's say this is stage 1 inductor 1 EM, and then this rest we have to change the simulator. It's called axiom stack up to the PE15 stack up. So that's all you need to do. So when I click this, it becomes red, but it doesn't get anything else red. Just notice that for the movement. You need to do one thing extra. You need to right click on the inductor, get properties, go to model options, then say EM extract options here, just enable it. Now it says enable it to this group, which is EM extract. So once you do that, when you click on the extract block, it gets highlighted. That means this extract block will look at whatever the highlighted circuits and extract to an EM block. So still we haven't finished the process, so we need right click then and then say add extraction. So once you do that, you will notice in the project you will have under EM structures something called stage 1 inductor 1 EM. Okay, so if you double click that, that's actually this one. So it created an EM for you. Now you don't need to change anything here. This is not the layout, so that's something you need to remember. So this is, it says EM here, axiom, but if you want to look at the layout, that's the layout. But they look very similar, but that's two different things. Layout has no idea what about the interactions and everything. It's just a layout. Okay, now once you do that, you need to simulate it. Now you can also look at the mesh if you want. So if you are in you can look at the mesh here. So that measures it. So as long as it has a couple of meshes in here, it should be good for simulations. Now the idea here is we simulate this first individually, so you can right click on this and then go to simulate. It'll probably take a while depending on how fast your PC is. Maybe it might take 2 minutes, 3 minutes in my one, so we'll just wait for that. So your project settings, your frequencies, like even though your project works only for 10 to 12, you may have to set your frequencies up to 100 gigahertz or something. That's because when you do EM, you want to do EM for a very high frequency, but the project has frequencies from say 0.5 to 100 gigahertz, but you just view things at 10 to 12 to 16 gigahertz range. So that's something you need to make sure in your project settings, which is in options, and then project options, set the frequencies to up to 100 gigahertz or something, because for EM it's important that you simulate it for high frequency, especially you measure it for high frequency. Okay, so it's getting closer. So you'll say calculate, you see that calculated solution at 87.5 gigahertz. So even though I'm not interested in that frequency, it still calculates it. But I think that's a good thing to do, and I think it's almost finished now. Okay, so we have EM results, and once you have the EM results, you will also notice in your data sets, you will have an EM results for, so this is stage 1 inductor 1. So you got EM results saved here. Now the idea here is, now when you go back to your LNA circuit, you should be able to get a sub circuit which calls stage 1 inductor 1, which is stage 1 inductor 1, which is this sub circuit, or you can actually get to the stage 1 inductor 1 EM, doesn't matter, but because it's the same, because it is just a circuit block for it. But anyway, so I get the stage 1 inductor 1, and the idea is to, okay, so before I plug this in, let me put things in the memory. So I'll just toggle enable this. I'll go back to S parameters, simulate this. So now it's just a circuit model itself. Then you can press Control F, it'll freeze the traces, or you can go to, I think in graph, freeze traces, Control F, see here. Then I'll go back to the schematic and then toggle enable this, connect this to here. So I'm going to replace the P15 circuit model, P15 inductor, which just analytically calculates inductance, to a EM simulated one. Now when I do that and I simulate it back again, if the curves change, I mean, let's see what happens. It has pretty much no impact at all. It didn't really change much. So because it's almost on top of the simulated previous on P15 one. So it's good. So it did the EM simulations, no issues. That's good. Now let's change the cap. So now what happens is, if you go to your layout, what you will see is this EM simulated layout. Actually, this is the EM simulation, not exactly, this is the layout of the EM simulated block. Okay, now if I go back, now I want to simulate the capacitor. So here I'm going to do something different to show you guys. Like I'll pick these 3 caps, and this cap, and then the adjacent blocks. So you may have this as thick. I don't know whether you guys have it as metal one or thick, doesn't matter. So I'll keep one thick, keep one metal one. Let's simulate it anyway, just to okay. So let's control freeze this. Then I'll take this. So I'm going to replace all of that after EM. So I'm going to EM all this part, then put it replace this with the EM block. So before that I need to make a block. So I'll go to not EM structure, circuit schematics, new schematic. So this is stage 1 C1. Okay, and then I will copy this, and then I need to add ports. Then the same thing as before, I'll get the EM extract block, then change it to stage 1 C1 EM. Just to keep it consistent, simulator would be axiom, and then stack up would be axiom PV. When you say stack up, it's actually in here, global definition in PV 50/100. This is the stack up it is talking. Axiom has a stack up, so you can right click and look at the properties, but I won't go into detail because I will cover this up in the layout lectures. You don't need it for the simulation. Just ensure you have the right stack up here. Then what you need to do is to assign this to extract block. So I don't need this anyways. This is the P15. So I'll click right, select all, right click, properties, model options, enable. Now when I click it, okay, it's there. Now when I go to the layout, so it is actually connected, looks like, at least. So okay, so that's the cap. This is the capacitor. So if you look at the 3D view, that's the top layer and there's a bottom layer. So the bottom layer comes in and connects. This is your port 1. The top layer comes and that's your port 2, but at the moment in the layout you can't see the ports. So we'll see the ports when you do the extraction. So if I go to stage 1 C1, I click that, it becomes red now. So I do the add extraction, it becomes a block. So you see port 1 and port 2. So that's port 1 is your input side, and port 2 is that goes to the inductor. Right, now let's simulate that. Let's look at the mesh. Okay, so it have automatic ports in here, that's okay. So we have to go back to the stage 1 EM structure. In here I will say simulate. It will probably take another minute or two. So while this is simulating, now in this video I've shown you like how to individually EM the inductor capacitor, but you don't have to stop at that point. So you can EM a whole block, but it's good practice to go from the lowest level block and then move up. So when you do EM for the inductor, you replace with the EM block. When you do EM for the capacitor, you replace with the EM block. Then after that you can actually include that T-junction, including capacitor, T-junction and the inductor in the one single EM block, and then replace that in the circuit simulation. So you go step by step and then make everything EM as whatever you can do EM, you'll do EM. The transistors you can't do EM for, because the P1500 process you can't do the EM on the transistors. Okay, so this is finished. So let's go for the circuit, and then what the idea is to replace this with the schematic. Now when I do that, because we put that in the memory, oh sorry, it's not here. So we toggle enable because we want this to work. I will see if there's any change. Almost no change. So the inductors and capacitors are pretty close, actually, the values it predicts, so that's good. The EM and the circuit level is not changing much, but you'll notice it will change as you do this for the whole block. Let's say, for example, I'm not going to do that, but you can now, so you replace that, but you haven't replaced these two, right? Or these ones. So you can actually replace that whole block with one EM, and then you might see if there are differences. So that's about the EM. Now we'll also have to keep in mind how you're going to lay this out. So for example, if I'm let me select these parts for now. So if I select them and go to the layout, they get highlighted, right? So I can just view where they are. Okay, so that's my capacitor. Actually, maybe I'll go to that LNA, select what I want, is these ones. Then I come back to my, and I'll do no, it doesn't let me do auto snap. Okay, I have to pick each one. So I have, this is the T junction, and that's the inductor. So I'm rotating the inductor. That goes up here, and then yeah, that's the transistor, and that's after the transistor. We just worry about, so what is this one? No, that's the other part, and that's the feed. See, so let's just worry about these parts. Then I do auto snap. You'll see things come and collapse, but this is the right connection. So you have a feed, RF feed here, then it goes in, goes to the transistor, goes out, but then you have the inductor, you have a path, and you have a capacitor. But you'll easily see that you can't really lay it out like that because you need extra space. So you need to move these two here, and which means you need a line in between this and that. So the way to do that is, if you go back to LNA, this line you need to increase the length of that. So maybe let's make it 150. Okay, so now let's do auto snap for this. Okay, so that's sort of all right. It's not 150 is not ideal. You can maybe get away with 120. Okay, let's see. Select them and then do auto snap. Oh, did I make a mistake? Oh, 120. Okay, maybe move this up. Okay, so that's sort of okay, but then you have this issue here. So you can either move this up. So if you want to move this up, you need to have another line in between here. So you need to have a line in here that can probably give you, say, 20. and then I go to the layout. Where is that line? That line's here. Move this up. What's wrong here? Oh, we had a short connection because we have this line. Okay, so that's okay because it's connected anyway. So now I come here. Okay, I can do again auto snap. Okay, so it's coming into a shape. It's probably not the best because when you do this, you see you're wasting a lot of space here. But ideally, if you have an inductor going up, taking the space here, then it will be much easier. What I mean is, if you can take this. Okay, when you simulate this, let's simulate this, and then you see it's slightly changing now. So you will notice actually this is changing for better because your noise figure is coming. Your studio is getting better, S1 slightly better, gains moving left, but you didn't lose much here. So it's not that bad whatever we did. It has worked in favor, but ideally you would also need to remember you will have some biasing lines. So this is your biasing path. So ideally you would like to have this rotated, and then you get the biasing lines, and then like that. This I'm just trying, you don't have to do it, but I'm just trying to show you guys. So if you had the inductor not like this shape, but if you have an inductor something like the same inductor, something like that, you'll save space. Right, so if you can do something like that, will save space. So there's a way to do that. I will show that in the next lecture on Monday, because I think that will take a while, and if I make that as part of this video, it will be a very long video, which is not very convenient for you guys and me both. So I will do that in the lecture next week on Monday, how to set up your own custom EMs and how to set up your own custom inductors and then EM them. Now the idea is you have, let me delete this too. So let's say this is your stage 1, right? So you will have, so these all scattered items here, you will have like properly arranged like that, and they will come one after another. So then you need to put that inside a frame. I will give you a template for the frame. At the moment I will, let me see if I have, so if the way you, let me see if I have actually a frame. I think I had one. Assessment. Okay, looks like I don't have I don't think I have a frame, but I will show that also in the next video, how to add a frame and how to add RF pads to this. Now I think that's so what basically the idea here is you'll do EM for each of the stage, each of the inductor, each of the capacitor, and then stage wise you can, when you progress, you can do a EM for the whole section and then see how things change. If things change, you might have to play with your inductor values again, or maybe change the length or change the capacitor values, and then get your spec, get your response within the spec. So that's the idea. So we'll stop here now. On Monday's lecture I will do more on layouts, and then I will also do how to do EMs for the custom made inductors. I think that will sort of finish you, that will give you like a full overview on how to do EMs, and then the layouts, which will help you for review 3 and review 4, as well as the lab coming up next week on Thursday. So I'll stop here now. Hopefully this helps you guys to finish up your review 3 quickly.